Welcome to chapter 2. In this chapter, we're going to look at how a computer works. So, the theory behind the working of a computer, that's what we're gonna look in this chapter. So, let's look at the agenda of this chapter. So, we're gonna discuss the idea of computing, what computing really is at the fundamental level. Then we're going to discuss a little bit about binary numbers because we're going to focus on two-based numerals in this presentation. That's what electronic computing uses, the silicon-based computing uses. Then we're going to look at different components of a computer or a chip, which are nothing but transistors, resistors, and diodes. So a little bit of electronics, basically. Then using those components, we're going to build or we're going to look into something called logic gates, then something called flip-flop. Then what we're going to do is we're going to make a circuit with those components, with those gates, in fact, a small computer or a circuit which adds two numbers. That is how we're going to end the chapter with. And we will see a couple of different operations like shifting operations, then XOR, or etc. So some additional operations which only binary numbers are capable to do. That's what the agenda of this chapter. So this is a quick review of this course so far. So basically we have seen in chapter 1 the components of a computer, and we built a computer, then installed operating system, installed two operating systems, and we looked at multiple things like devices and stuff like that. We discussed that CPU is the most important part of a computer, but we didn't explain how the CPU internally works. We saw that chip and motherboard and everything. We didn't explain or how it works internally. So that's what we're gonna do here, what's inside the CPU. So rest of the components, everything else we're gonna leave in this chapter. We're gonna try to look inside CPU. We are not going to look inside a fully fledged CPU like the AMD CPU which we used or Intel CPU, but we're gonna get a feel of how a chip like that could work internally. So put a little bit of context of why this is important. So in my childhood, I tried to understand the working of a calculator. As a kid, I used to open pretty much every devices, tape recorder, iron box, motor, dynamo, everything. Every device when I opened, I used to find interesting things, and I used to understand. I still remember the day in which I was so curious about how a speaker works, and when I opened, I could understand there is a coil inside, there's a magnet inside. Then I knew the electromagnetic principles, and I understood how it works. It was easy to understand whenever I opened a device to understand what the device is. Similarly, I tried to open up a calculator. The calculator I tried to open it up, and I opened a calculator and it was pretty empty. All it had is one single chip and couple of keys. I couldn't understand. Then it had a LCD, small liquid crystal display. But I was so disappointed that I couldn't understand how it works, how it adds two numbers so accurately every time without fail, how it does that. So I had to wait so many years to understand that. So this is how we are having this chapter to understand how simple calculations does work in electronic devices. So being said that, we're gonna discuss less of physics around it. So basically, I'm not going to discuss the working of a transistor or a diode, or we'll see what those things are pretty soon. But we are not going to discuss how it works, or a p-n junction, or N-type impurity, p-type impurity, not that part of the electronics. So we will be using water, the actual water, flowing water, the analogy of water we will be using instead of getting into the real electronics. We'll have a keen focus on the computation itself. So there is this computer science subject called theory of computation, which I feel a very important subject, but has been notoriously complicated. I mean, a lot of students find it difficult. We are not going into the details of theory of computation as well, but this could be a very, very light version of that particular subject.